Hey guys, I'm Pat Kelly. Okay, in this problem, they give us another one of these binomials, in this case x plus 2y, raised to the fifth power in this case. The directions tell us to use Pascal's triangle to determine the coefficients, and then to expand the binomial, okay? So you can see what I've already started with is Pascal's triangle. I know you recognize that guy. I didn't take the time to write it out with you because I know you could do these rows on your own. Remember, you're just adding the two numbers above to get the next number down. Okay, always starting with the ones. And it's definitely a skill you want to have is to be able to throw that triangle together, like even in the margin of your paper, without too much thought. So practice that. You'll be glad you did. And the only thought I might have right here in this problem is, how far down do I have to go? How many rows of Pascal's triangle do I need? And to get the answer to that, I'm going to go back to the original expression. And the original expression really always offers us three pieces of the puzzle that we're going to need to put together. The first piece, I might say, is your n value, which is always just the exponent. N equals 5 here. Let me put the other two pieces of the puzzle on the back burner for a little bit. We'll come back to them. But that n equals 5 tells me where to go in Pascal's triangle. But there is a trick with Pascal's triangle you want to always remember. And the trick is that first row is row 0. You're always starting with 0. And so it's the second row that would be row 1, row 2, row 3, row 4. Here's row 5 for me. That's the one I want for this problem. That's how I knew how far down to go in Pascal's triangle. Okay? So that tells me, getting back to what they wanted me to do, is that these are the coefficients for my expanded expression. So you will definitely see these guys show up in about a minute or two as coefficients. All right. So now let's continue back to the binomial that they gave us. They want us to expand it, and just go down here for some space. This equals, and I do still have those two pieces of the puzzle on the back burner, but I want to play around a little bit more with what you should know from that first piece, that n equals 5. What that tells me right off the bat is, okay, well, this row gives me my coefficients, but then it also, that n value, also tells you your powers of the variables. So my first coefficient is going to be 1, and then the variable x is to the fifth power, because that's my n value, okay? Plus, and I'm going to look to my next coefficient. In fact, maybe I'll even do that in, what did I circle it in? Green. That 5 is my next coefficient, okay? And then x, and that power of 5 we had in the previous term bumps down to the 4 power, and now we'll have y to the 1 power. Plus, I need a coefficient. I go up here and see the next entry in the row was 10. So that's my next coefficient of 10. X, it was to the 4th power. It now goes down to the 3 power. You can see that 4. This y is actually going to start building up powers. So that was to the 1 power. Now it's to the 2 power. Plus, I need a coefficient. The next number in the row of Pascal's triangle is also 10, so I have another coefficient of 10. And then x needs to go down to the 2 power, and y goes up to the 3 power, plus my next coefficient from the row is 5. Okay, and then x goes down to the 1 power, y goes up to the 4th power, almost there. Next coefficient is just 1, and then x drops down a power again. Now it's to the 0 power, so it's just a 1, and y goes up to the 5th power. Okay, good. Pat yourself on the back for that. Just getting those coefficients and getting started with our expansion of the binomial. It's just a start, because now I did mention those pieces of the puzzle. Keep putting on the back burner. Let's get back in the original problem. Let's get those, okay? And the other pieces of the puzzle that you need are what x equals and what y equals. Just be careful with this. When I say what x equals and what y equals, I actually even put like quotes around it, like quote unquote x and quote unquote y. Because the way you get the expression there that you have for each of those is to go to the binomial, and x is always just the first term of your binomial. So that's just x. Okay? And I know that looks convenient or coincidental, but that x is actually whatever I would have right there as my first term. If there's a coefficient, if there's a power, whatever's there, that's your expression for x. Okay? Similarly, for my y, quote unquote y, I've got to look up to the binomial and look at the second term. The second term does have a 2 there as well as a y. So both of those, 2 and the y, are going to be what I grab for my quote unquote y. Okay? Be careful of that. Especially, let me give you a little tip, make you a little bit better than your neighbor, your friend. If this were subtraction on the inside, that minus gets carried down into what we're labeling as our quote unquote y. Very common mistake to forget that. I don't want you to make that mistake. Okay? All right, so what that tells me, now down in my next step, is wherever I have an x, this is the easy part, I just replace it with x. But wherever I have a y, I need to replace it with 2y. Okay? Let's reflect that in our next step. X to the 5th plus 5x to the 4th. And instead of y, it's actually 2y. And I'm going to advise you to use parentheses because it'll help you when you get into exponents in your later terms that we'll see actually in a minute or two. Actually, less than a minute. How about a couple seconds? Where am I here? 10x cubed. But this y, I'm going to put parentheses 2y. See, because that's raised to the 2 power. And I want to make sure in my next step that I get this 2 raised to the 2 power as well as the y raised to the 2 power. Plus whatever else would have been included in your quote-unquote y. Okay? All right, let's keep going. Next term would be plus 10x squared, parentheses 2y all to the 3 power, plus 5x parentheses 2y all raised to the 4th power, plus parentheses 2y all raised to the 5th power. Okay. All right, all that's left is actually arithmetic. Let's compute this and simplify it a little bit. I say arithmetic because all I'm really going to do is use these 2's inside the parentheses, raised to powers where appropriate, and also multiply by coefficients where appropriate. Okay, so x to the 5th is still x to the 5th. This 2 I'll multiply by the 5 and get 10. X to the 4th, that y is just to the 1 power, plus, okay, 2 squared is 4, but multiplied by the 10, we'll get 40. X was cubed, and the y does get a 2 power, plus 2 to the 3 power is 8 times the 10, 80. X is squared, y is cubed, plus 2 to the 4th power is 16. 16 times 5, I think I'm getting 80. X to the 1 power, y to the 4th power, and then plus, last term, 2 to the 5th power, that's 32, and y to the 5th power. That's our final answer. It's a good one. I like it. Practice some more on your own. Okay?